Hello, welcome to the second video of this series of working through our past paper. Today we are going to be tackling two questions, 1.1.3 and 1.1.4. We will be releasing about a video every day or two, perhaps two videos if we have time. And in these videos, we're hoping to give you guys insights into how to solve every question in the grade 12 mathematics paper 1. And we will do paper 2 as we build up and get closer to the final exam for the matrics for 2020. All right, so let's get straight into it. Today's question is the square root of 3 minus 26x is equal to 3x. How do we solve this question over here? So let's get into it. Let's see. We have the square root of 3 minus 26x. Okay, that's equal to 3x. All right, so how do we do this? Well, the nice thing about equations is that you can actually do anything to the left-hand side as long as you do that exact same thing to the right-hand side also. So what we could do here is we could just square the side over here. And we know that if we square root, it basically cancels each other out. And what we do on the left-hand side, we have to do on the right-hand side. So we have to square the side and the side also. So what are we left with over here? Well, we just left with what is under the square root, 3 minus 26x. And on the right hand side we square this. Now note that when we squaring, well, this is one term, but it's 3 multiplied by x. When we're squaring something multiplied by something else, we have to square both of those things in the bracket. So this becomes 9x squared. Okay, notice as a side note that 3x all squared is very different to, it's not the same as 3x squared. I've seen this mistake being made by some students. These two are not the same, just a side note, okay? 3x squared means you have to multiply 3x by 3x, which means we get 9x squared, and 3x squared is just 3 multiplied by x times x, okay? Just a side note. All right, so then we left with 3 minus 26x is equal to 9x squared. And what we could do is we could put everything onto one side. We could take it to that side, or we could take it to that side, either way, right? For the sake of just making this very simple, we could just bring both of these over here, 3 and the 26x. So then we left with 9x squared plus 26x plus 26x plus 26x minus 3. Brought it over, and what we left on the side is 0. And again, just a nice easy thing that you can do always. You could always just swap things around. What's on the left hand side, you put everything on the left hand side and the right hand side, and what's the right hand side, you put everything on the left hand side, simply because what this essentially just means is that 0 is equal to that. So that means that 9x squared is equal 9x squared plus 26x minus 3 is equal to 0. It's the same thing, right? We're just writing it in a different way. And the reason why I'm doing this is because we are used to working from left to right and not right to left. Okay, you could have left it like that if that was easier for you, but I'm just trying to follow a nice clear thought process. Now we have this quadratic over here, and we need to solve this quadratic. Two things: you could solve this quadratic by using the quadratic formula, which is x equal to minus b plus minus square root of b squared minus 4ac over 2a. That formula, by the way, is available in the formula sheet which you are provided with. Although if you went that way, which you could, you would get the answers, but you would lose marks, because in the memo you actually get marks for factorizing this. So I'm going to show you how to factorize this quadratic over here. How do we factorize a quadratic that has a coefficient in front of x squared? Well, the way you do it is you need to list the factors of both the coefficient of the x squared term and the coefficient of the constant term. So the factors of 9 is 1 and 9, and 3 and 3. And then we have the factors of 3, or negative 3 if you want, which is going to be 1 and 3. And what we're essentially looking for is, we need to open two brackets, okay, and we're looking for a combination of one of these two factors that would add up. When we multiply them out, they will add up to the middle term. So we have our x and our x over here, okay, and the first one we're going to try is 1 and 9. So we could try 1 and 9. If we put a 1 over here, We could put a 1 over here, and a 9 over there, and then we have the other option. We're lucky enough to have only one option for this, for 3. The only factors of 1 and 3 is 1 and 3, since it's a prime number. So we know there's 1 and 3, and we know one of them must be negative because it must be negative over there. So one of them must be negative at least. So when we multiply this out, this is basically trial and error. When we multiply this out, we need to get the middle term. So when we multiply the first two terms, we have 1x times 9x, which is 9x squared, the first term over there. And then we say 1x times 3, which is going to give us 3x over there, right? And then we have 1 times 9 is going to give us 9x. Now the question is, can we combine 9x and 3x to get 26x? And the answer is clearly no. There's no way I can add or subtract 9x and 3x to get to 26x, which means something is wrong. We could potentially swap swap the values around. So instead of us having the 1 and the 1 together, we could put the 9 here and the 1 over there. So we swap this around. And you have to, by the way, try both combinations. Instead of us putting the 1 there, we put the 9 over there and we try it again. So if we have the 9 over there, then 9 times 1 is 9x, and 9 times 3 is going to give us 27. Very close to that over there, 26. And then we have 1 times x, which is going to be x, of course. And we can combine 27x and x by putting a subtraction sign between them. 27 minus 1 is going to give us 26. Therefore, this term must be negative. And because this term must be negative, we can now establish that the 1 times that must be negative over there, because negative 1 times x gives us negative x, and that must be positive over there. Since 9 times 3 must be positive, 27x minus 1x gives us 26x, and that means that this over here, these two factors over here, are the factors of that quadratic over there. Remember again, this that I wrote here at the bottom of here is just a test to see that I have the proper factors, and we just saw now that the middle term adds up to 26 when we multiply these two, which means that these are the correct factors over here. Okay, so now we have these two factors over here. Now we just follow the method that says that if two factors are multiplied by each other, then if their product is equal to 0, then that means either 9x minus 1 is equal to 0, or x plus 3 is equal to 0. And since that is true, we know that 9x must equal to 1, which means x must equal to 1 over 9, or x is equal to negative 3. And that's how we solve that one over there, right? Note that, this method that I solved over here, it's a trial and error method, which means you have to test. Firstly, you have to test 1 and 9 for the coefficients of x. If 1 and 9 doesn't work, you test 1 and 9 for the coefficients, and 1 and 3. If that doesn't work, then you swap it around, 9 and 1 and 1 and 3. If that didn't work, then you would swap the other two factors around. You try 3 and 1. And if those don't work, and then you have to go on to the next two factors. So it's a trial and error method. If you do a lot of these, you start to see the solution, as per most of the questions, by the way. Most of these questions, if you do a lot of examples, you start to see the solutions, and it starts to become easy for you to see it. But I hope that's clear. So these are the two answers over here. You get this question is worth 4 marks. Okay, you would get a mark for let's just give you the breakdown of the marks. The first mark you would get for actually squaring that, so that's 1 mark over there. The second mark you would get for putting it in standard form, that mark over there. The third you would get for the factors, right? 1 mark for the factors, and the fourth mark you get the answers. Okay, there we go. That's question 1.1.3. Let's move on to question 1.1. All right, 1.1.4. Well, this question is an inequality, and we need to deal with inequalities in specific ways. So the inequality states that we're looking for what the value of x is. Remember, we're solving for x. Question 1 is all about solving for x. We're looking for the value of x such that when I multiply x minus 1 by x minus 4, the product is actually greater than that same x plus 11. That's basically what I'm looking for. I'll repeat that. When we multiply x minus 1 and x minus 4, we want the answer to be greater than x plus 11. That's what we're looking for. Okay, it's important to understand the question. So how do we solve this over here? Let's get into it. X minus 1, x minus 4 must be greater than x plus 11. Okay, so how do we tackle a question like this? Well, the first thing that we want to do is we want to find what we call the critical points. Now, the critical points, remember, this is actually, if you look at this over here, okay, how do we tackle this over here? Well, the first thing that we have to notice is that this is actually a quadratic. Okay, this is actually a quadratic. How do we know? Well, this is a product of two binomials. Okay, and they're going to give us a trinomial. So we have x squared minus 5x. If we multiply this out, we'll get x squared minus 5x plus 4 must be greater than x plus 11. What I did here was I just said x squared, x times negative 4 is negative 4x, and minus 1 times x is minus x. And when we put minus 4 minus 1, we get minus 5x, and then we said negative 1 multiplied by negative 4, and we got positive 4. So that's what we got over there. So now we notice that it's a quadratic, which means, and it's actually a positive quadratic, it means that if you remember from graphs, this is going to be a parabola, okay? Something like that. And every parabola has what we call, we could call them roots. We could also call them x-intercepts. In this case over here, we call them critical points. Why are they called critical points? Well, this graph actually represents the function, right? Some quadratic function over here. That's what it represents. And that function over there, it crosses the x-axis at some point. Now, if you remember correctly, the moment it crosses the x-axis, its y value actually becomes positive. So anything above the x-axis is actually positive, and anything below the x-axis is actually negative, right? That's what we have over there. So we're going to use this as a reference to figure out where this graph is positive or negative. How does the positive or negative part come into this question? Well, I'm going to bring this part over here, and I'm going to bring this x over here and this 11 over, and I'm going to have x squared. I should have probably done this before I actually explained that diagram over there. But we're going to need a diagram anyway. Minus 5x minus x, if I bring this over, minus x plus 4 minus 11, right? We can keep the greater sign, is equal to, read it as an equal sign, but it's actually a greater sign. Just keep it as is. We deal with this as a normal equation. 0. We took everything over, so there's 0 there, right? And if you combine this over here, we have x squared minus 5 minus 1 is minus 6x. Okay, and 4 minus 11 is going to give us minus 7. And we're saying that quadratic must be greater than 0. Right? So now we're going to solve this as if we were solving a normal quadratic equation that's equal to 0. Right? So how do we factorize this over here? So the way we factorize this over here is, well, we're looking for the factors of 7, negative 7, that when I add them together, they're going to give me negative 6. So let's list the factors of negative 7. Well, 7 is a prime number, so it's going to be 1 and 7. So we open up our two brackets. And we just need to figure out how do we combine these two to get us negative 6. We have x and x as the first two terms, and then we have 7 and 1. Okay, and the way we combine these two is going to be, well, negative 7 plus 1 is going to give us negative 6, and negative 7 multiplied by 1 is going to give us negative 7. So there we have x minus 7 and x plus 1 must be greater than or equal to 0. Okay, now we got this part of here, x minus 7 and x plus 1. So we're going to solve this as if it's a quadratic equation that we're making equal to 0. And when we do that, we will have that x minus 7 is equal to 0, or x plus 1 is equal to 0. Why are we saying equal though? The reason why we're saying equal is because we want to find the critical points. And once we do this, we're going to see that x is equal to 7, or x is equal to negative 1. Right? So those are the critical points over there. Now comes the interpretation part. What are we looking for? We're looking for where this quadratic is actually greater than 0. In other words, where is this quadratic positive? Where is this quadratic positive? Well, clearly, It's positive where the graph actually goes above the x-axis. So for any value that is less than, remember anything on the left hand side is actually less than. For any value of x that's less than -1, that would ensure that the graph is positive. So the first part of this answer is x is less than -1. Okay. And the second part is going to be where x is greater than 7. Because as we can see, where x is greater than 7, the graph itself actually goes above the x line. So the second part of this answer is x must be greater than 7. Right? We could write all there of there. It could not be between -1 and 7, because anywhere between -1 and 7, the graph itself is actually negative. And that's how we interpret it. That's how we interpret it. For any value of x less than -1, the graph actually increases. It actually goes above the x-axis, which means that it will be positive. That's what we're looking for over there. And for any value greater than, remember greater than is anything to the right, greater than 7, the graph will be positive because it's increasing above the x-axis. And that would be the answer. Note that you cannot solve it by just doing this. You cannot solve it by just doing this. Okay. If you did this, you would not necessarily get the right answer. Then this would be x is greater than 7, or x is greater than -1, if you did it that way, right? Which is not the case, because we just showed over here that x must actually be less than -1 in order for the graph itself to be positive. That's important. So this you can't do. You cannot put greater sign over here. It simply won't work. The only reason why we're doing this part over here, the section over here at the bottom, is to get the critical points, which we will then be able to use those values to determine where the graph is positive or where the graph is negative. I hope that's clear. Thank you very much for watching today, and don't forget to like, subscribe, share this with anybody who might find this beneficial, and yeah, thank you very much. Have a good day.